Welcome to this session. I'm going to talk about how to build an offline experience with the Rails-powered PWA. So a bit about me. I'm a software developer at Dallas Labs. This is my part-time job. I'm actually a music composer, the other half of my productive time. I was a natural resources engineer before this, so that's where my passion about technology and sustainability comes from. And actually, the case study that I'm gonna talk about, it comes from that background. So, as a quick overview of this presentation, I'm gonna define first what is a PWA and why I think they're awesome. Then I'm gonna briefly cover the case study. And then I'm going to explain the main two assets that are required to turn your Rails application into a progressive web app. And then the substance, the main substance of this presentation, which is how to perform offline create, read, update, and delete, quote unquote, actions. And finally, some key takeaways. So, a PWA is an acronym that stands for Progressive Web Applications. So these are just web apps that use service workers and manifests, which are two assets that I'll explain later, and other web platforms features in combination with progressive enhancement to give users a boosted experience on pair with native applications. So this enhanced capability can be such as page performance, push notifications, or in the case of this case study, the offline support. So this gives PWA enhanced capabilities, reliability, and installability. So I like to think about PWAs as the mix of best of the native and web worlds. So this is a common chart that I've seen in the web. I've seen some versions of the chart where PWAs and native applications are kind of the same level, but I think that because native apps are so platform specific, they can reach more capabilities than PWAs, but still I think PWAs are a pretty good deal in terms of the budget friendliness. You can install them, but it's not required, so you can just use them from the regular browser. You can have search engine visibility, which you don't in native applications, and so on. So I think this is a pretty good deal for a web application. So the case study. This was an application that was requested by the Chilean government, and it was meant to be used by farmers and farm technicians in the field in order to diagnose their fields, their farms in terms of sustainability. So it was kind of a complex survey that they will fill up and they will show the results to the farmers in the field. So as you can imagine, the offline support, it was very important because we're talking about farms and rural areas where internet connection is not very reliable. So we really needed to tackle this challenge fast and in a maintainable way. So this is the way it looks. It's a complex survey. It has file uploads, maps, lots of questions. So we needed to provide a way for this farmer and farm technicians to fill this form offline. So the solution we came up with was to build an application with our favorite framework, which is Ruby on Rails. So we could just provide value as fast as possible to our client, and then we would progressively enhance it with the PWA features. We considered to build a native application, but this would require both a Rails API and the native code. So this would disallow a web experience without an additional web frontend. So we wanted to have a single code base, and efficiency and maintainability were really key because of the budget constraints. So I'm kind of homesick now. So this is just all images from Chile, where I come from. So how to turn your application into a PWA, the main ingredients. So these are two assets. The first is the service worker. So the official definition is that service workers are specialized JavaScript assets that act as proxies between your web browser and the web server. So there are, like, in the middle of them, intercepting requests and improving reliability, boosting page performance, like all sorts of enhanced capabilities. But the key part here is that service workers are an enhancement. So there might be cases where your client does not have browser support for service worker, but this means that no base functionality should be broken because they're, again, an enhancement. So I like to think about service workers like a small application that's running in parallel to your Rails application, and it's kind of there in the middle, intercepting requests and doing different kinds of things. So the scope is important. It should be available at the root scope because this is reflected in the scope that your service worker will be capable to control. So we want it to be at the root scope so it can control all the pages within your main web application. So this is kind of an example. This is not like an actual service worker look like, but I wanted to show these callbacks. So the service worker works based on a lifecycle of events that are triggered in the browser, and the service worker can listen to them. So that's why I added those event listeners at the end. And every time it hears or it listens for one of these events, it triggers this callback. So you fortunately don't have to write these callbacks by yourself. I recommend to use a library that's called Workbox. It's the link, it's at the end of this presentation, which allows a more programmer-friendly syntax for writing your service worker. So the second main ingredient here is the app manifest. So this is a JSON file that will tell your browser how your PWA should display within the operating system of your user's device. So this is an important file to make your app installable, and that's to make it look and feel like a native application. And same thing here with the scope. It should be available at the root scope. So this is more or less how a manifest look like. In this case, I used json.erb because I wanted to use some of the Rails helpers. So I could just, for example, display my home screen icon, which is the icon that will be added to the home screen of your user's device when they accept the prompt to install the application. I don't know if any of you have ever entered a website and you're prompted to add the home screen icon. So that's probably because these applications have a web manifest. And other things such as the display, the color, and here the kind of web browser display that you want to choose. I chose standalone because I wanted to resemble as much as possible a native experience. So I'm not going to dig into how to add these files in your application because I wrote a very detailed blog post on this topic, and I have little time, so I just left the link there. But I want to dig into how to create records in your application and sync them later. So there are two main APIs that I used here. The first one is IndexDB. So in terms of browser storage tools, we have different options. We have cookies, session storage, we have local storage, and we have IndexDB. I chose this one because it's very powerful. You can store pretty much everything from like JSON objects to even files, blobs, images. It has persistence across sessions and across browser tabs, so that's very powerful. And it's a JavaScript API. It relies heavily on promises, so it's recommended that you have an at least basic understanding of promises when you deal with this. But even if you do have a strong foundation, I recommend using a wrapper. I promise it will be easier. So wrappers are JS libraries that allow a more programmer-friendly syntax for using IndexDB, and they come in different flavors, different functionalities. So you don't have to deal with this promise syntax like plain. So the other tool is the background sync API. And this is a very powerful tool that allows web applications to defer service synchronization work to their service worker, so it can be handled at a later time. So the browser will basically detect when the connection is back, and it will trigger the background synchronization. So the implementation works more or less like this. We have our server on the left side, on the right side, and our client in the left side. Let's suppose we have a user that's just completed a survey and they want to make a post request to your server. But the user is not connected to the internet, so this post request will fail. So this is where IndexDB comes to play. We will catch this object and store it in IndexDB. So the entire survey that your farmer or your user completed, it's now stored in IndexDB. And then the background sync will later detect when your user is back online and will attempt the request again, taking the object from IndexDB. And now we have a synced server. So in order to do this, we need to perform several steps. We first need to check the network status. So for this, the simplest solution that we found, or better, the most effective, it was through a polling. So we had this 1 pixel image stored in our server. We would exclude this image from the caching paths of our service workers. So this image would never be cached. It will always be fetched from the server. And every time we would do this, like every 10, 15 seconds, we would store a Boolean value in our local storage that we would use as a source of truth to know whether we are online or not. Then we need to declare or find an already created database with our wrapper for IndexDB. So every time we would submit a form, we would check the network status, and if no network was available, we will store this object in IndexDB instead of performing the actual post request. So as a pro tip here, very quickly, we found out that these actions we were performing in different places. So in order not to repeat ourselves, we ended up using stimulus mixins. So we would have a mixin for checking the network status. We would have another for declaring a database. So the implementation of the actual function to perform the background sync looks more or less like this. We would first register the event under a certain tag. Then we would match this tag with the event listener that we registered for this sync event. So every time we would trigger this, we would listen this event, we would trigger this function, which is sync service. So in this case, I'm using my DEXE syntax. DEXE is the wrapper that I chose. So we would first query the database to know whether there are services or not. And if we find service, we would store them in an array. We would declare another array that I will explain later, which is service IDs to remove as an empty array. So we would then iterate through this array and perform an AJAX request to your server for each one of them. And if the response was successful, so we make a post request for a survey and we get a successful response, so we take that ID and we push it to this IDs to remove array. And we will loop through all our surveys. And finally, we would, when all surveys were already synced, we would loop through the service IDs to remove those objects from IndexDB. Because once we synced a survey with the server, we no longer need that object in IndexDB. So thanks, Lori. What if we want to enable manual synchronization? So there are a number of reasons why a user would want to have more control over when this happens, because background sync, as the name says, occurs in the background. So the user has no control over when this happens or under which conditions. So we might have, for example, a fail sync, or the fact that some browsers don't support background sync because, for example, some privacy-centered browsers, such as Brave, that does have it, but they have it disabled by default. So among other reasons, we wanted to give our users more control over when this synchronization happens. So in order to do this, we used stimulus again. So the way we implemented this was connecting a stimulus controller to a sync button that we will use, for example, in our index. So we would have our index of service, and we would have there a button that would say like sync. And that button would be connected to a stimulus controller that would perform the same operation that I just showed you. So the previous function was in the service worker, but we could use the same function in a stimulus controller to trigger it manually. So this is about the create, right? But what do we do if we want to read this data? So we just created an object, we stored it in IndexDB, and this is how it looks. But we don't want our users to go to the developer tools window to see this object, right? So we want a way to display this information to the user in a friendly way. So again, here we use a stimulus to read this IndexDB data. And then we use a library called Mustache to render this data in the HTML that the user can see. So for each survey that we would find, we would iterate and then perform a JavaScript function to add this item to the DOM. So for this case, HTML templates are your friends. In case of you don't know this, HTML templates are a special tag that is rendered but not actually displayed. So when your user is online, it will render the page. This template would be loaded, and then we can use stimulus and mustache to bring this template, populate it, and then render it to the user with the information taken from IndexDB. So this is how the syntax looks like. This is a template tag, and we're using here mustache syntax to pass then the attributes from the object that we stored in IndexDB. So that's what I just said. We use these two libraries to populate the template and render it. This is how the function looks like. And I'm kind of running out of time, so I'm just going to skim through this. This is how the index look like. So this is the button I just mentioned. This button would be connected to stimulus, so we could trigger a manual synchronization. We have a toggle here that would show us the network status. This would use the local storage value that I just mentioned as a source of truth. We would have this icons to tell the users whether these items are synced or not. And yeah, pretty much that. Same here with the update. We would use a template version of the survey, like the entire form, we would put it between template tags. So when the user clicks this button, that template version would come up rendered using the values from IndexDB. So yeah, pretty much what I just explained. So some gotchas here. One important thing is that validations must match in the front end and the back end, because we don't want invalid objects to be stored in IndexDB, because that would cause a failure when making the synchronization. So we want every object stored in IndexDB to be a valid object in active record. So this kind of makes the challenge of duplicating some of the validations, but it's really important. And the other thing is that it's really important to understand your audience to assess the importance of this browser compatibility for some of the features that I mentioned, IndexDB, background sync, because there are differences among like Android users and iOS users. And depending on your audience's most used browser, you might have to assess the compatibility. So that was it. I hope this was I hope this was a meaningful presentation. So PWAs features can supercharge your application. You can make it suitable for anyone, everywhere. You can start making an impact by reaching unconventional audiences, such as people in rural areas. And finally, Stimulus is a super powerful tool for enhancing our application with offline features. You can pretty much emulate a single page application behavior with like minimum JS. And these are some of the resources I mentioned. And that was it. Thank you very much.